So in this video tutorial, we'll see Vlsi lab part B, that is experiment number 1, that is CMOS inverter. So to begin with, we'll use electric 9.07 software or electric 8.9. So in my system, it is electric 9.07. So I will click on that tool and we'll get this window. So we can add this windows in this manner. So we can arrange the tiles in this form. Then if you see no name, you can delete that file, like right click on that file, no name, and close the library. You can close the library. If we have any existing library, we can close that. So the first step will be go to file, go create new library, then give the library name for this as CMOS lab 1. Okay. Click on and give the library name as CMOS lab 1. Click OK. Then go to, so we can see in the Explorer tab. So look at the Explorer tab. And if I click on this plus sign, you can see your library CMOS lab 1 is created. So the library is created now. Next step will be go to cell, click on new cell. So we will get one more window like this. Then give the name for this, the cell name has inverter, give the cell name as inverter, and in the view we can select schematic and click OK. Give the cell name as inverter and select the view type as schematic and click OK. So you can see now the library CMOS lab 1. If I click on that plus sign, you can see the cell name what we have created just now will appear in this library, that is inverter in bracket SCH, that is nothing but the schematic. So you can see this window, which is a white window. It is a blank window. So if you want to get grid lines, if you want to get the grid lines, you can press the shortcut key, that is Control G. If you press Control G, you can see you will get grid lines like this, a dotted lines. Window will be a grid lines. You will get a grid line window. Then if you want to zoom in and zoom out, you can press, we can make use of Control 7 and Control 0. Control 7 and Control 0 to zoom in and zoom out. So keep in mind, to zoom in we can press Control 0 or Control 7. So you can press and try it out the shortcut keys, that is Control 7 and Control 0. So if I press Control 7, it will be zoom in, and if I press Control 0, it will be zoom out. So those are the keys are used to zoom in and zoom out. Then, so I will make Control 7, I will press Control 7, so it will be zoom in. Then, so we'll draw the schematic of CMOS inverter now. So to draw the schematic of CMOS inverter, go to the component tab. So beside Explorer, we have the component tab. So click on that and you can see we have the list of components available here. Okay, so to begin with, first you select PMOS. You can select PMOS, then just move the cursor, just move the mouse and place wherever you want. So the PMOS will be at the top. Okay, I will place it here. Okay, similarly I will select NMOS and I will place at the bottom below PMOS. Similarly, we require two other components, which is power supply. So the circles here, two concentric circles we have here. So select that uh, component and place it above PMOS. Similarly, you take ground and place it below NMOS like this. So keep the components in this form. Then we'll make the connections. We'll make the connections according to the schematic of CMOS inverter. So like if you want to connect from this power supply to this PMOS, then what I will do, So suppose this is the source and this is the destination. So first you click on left click on the source, so it becomes a red box like this. And on the destination, so so I want to connect to this terminal, so I can just right click on that. Right? So you can see this, the connection is made between these two components. So I will repeat. So left click on the source and right click on the destination like this. Okay, so I will repeat. So left click here, left click of the mouse, and right click on the destination, that is right click of the mouse. Okay, so similarly the gate of PMOS is shorted to the gate of NMOS. So we have to make the connections between the gate of PMOS and the gate of NMOS. Okay, so similarly left click, then right click, and the destination right click like this. So this is how we can make the connections. So I will repeat once again. So I will start with the source. So this is the source. Okay, so this is left click here, then here right click, right click, and right click like this. So this is how we can make the connections. So similarly, this is the source, this terminal is the source now, and this is the destination. So left click and right click like this. Okay, similarly left click and right click. So we have made the connections. Then for this, if you want to change the width and the length of this transistor, that is PMOS transistor here, if you want to change the width and length, we can change that by double clicking on the transistor. Okay, so I will I will double click on this PMOS transistor, and I will change the width to 20. Okay, I will change the width to 20, that is 20, and I will keep the length as 2 as it is by default. Okay, so I see that we can, so the see, you can see the width we changed to 20. Similarly, I will change the width to, or width of NMOS to 10. So I will double click on the component, that is NMOS transistor, double click, then you can change the width to 10. Okay, like this. So what we have done, we have changed the width of both the transistors, that is for NMOS we have changed to 10, whereas for PMOS we have changed to 20. Okay, then similarly we have to change, we have to give the name for this particular transistor. We know that it is a PMOS, but the simulator will not understand whether it is PMOS or NMOS. Okay, so we have to give the name for this particular transistor. So how to give the name, just remember, select the PMOS transistor, then go to tools, simulation, and click on select set spice model. Okay, so you can see spice model will text will appear on that particular transistor, that is spice model. So to change this text, that is spice model text, we have to select that particular text. You can see when I click on that particular text, that is a cross mark will appear on that particular text, that is spice model. Then you can press Ctrl I, you can press Ctrl I when it is a cross mark like this, when it will appear cross mark like on the text. So that you press Ctrl I, so you can see, you can see here a text property window will appear when I press Ctrl I. Then you can give the name for this as PMOS. You can give the name as PMOS for this. So you can see now the name will appear on that particular transistor, that is PMOS. Similarly, for NMOS, select NMOS transistor, go to tools, then go to simulation spice. In that simulation spice, you select set spice mode. Okay, so again you can see a spice model text will appear on the particular transistor. Then you can select this, so we can see here again uh, a red cross will appear on that spice model. When it appears, you press Ctrl I, so you can see a text properties window will appear. Then you can rename this to NMOS. Rename this to NMOS. Okay, so we have given now the name to both the transistors as well as the width we have changed. Then we have to connect the input and output to this particular schematic. So to give the input and output to this particular schematic, so you can make use of this components. So that is export. So I'm using this from the component list. So I'm using this symbol, that is export. This is nothing but export node. Similarly, you place it at the output here. Okay, so these are used for input and output connections. So from here, from this point, that is the tip that is on the right hand side. So I will click on left click and right click on the destination. Okay, so this is for the input. Similarly, for the output, you click on the back end side. That is on the back end side, you can click on this left click and right click like this, connections. Okay, so you can, if you see, if I click on this node, you can see the path is highlighted. See, you can see this path. This path should get highlighted when I select the particular node, the export node. Similarly, if I select this particular node, this path should get highlighted. Okay, this path should get highlighted. Right. Then we will give the name for this particular node. So this is, we know that this is the input node and this is the output node. So I will select this. So if I select this, you can see the path is see the path will get highlighted. So when this path will get highlighted, you press Control E for export, E for export. Then you can give the name for this as in. Give the name for this as in. Okay, so this node or this export node as in. Similarly, if I select this, the output node, so select this export node and press Control E, and give the name as out. Give the name as out. Click OK. Click on OK. Like this. Okay, so we can rearrange this text wherever you want. Okay, like this. Right now, you can save this. Okay, you can go to this file and you can save the library. Okay, so a window will appear and press click on save. Okay, so go to file, or there is a shortcut option here of to save it. Then so this schematic is ready now. The schematic is ready now. Then we have to simulate this circuit. So to simulate the circuit, we have to write a code which is called as a spice code. Okay, we have to write a code which is called as spice code. Spice code, that is SPICE. SPICE. That is the spice code. So to write the spice code, go to the component tab, and in the component tab go to MISC. Okay, the MISC option is there here. MISC is nothing but miscellaneous. So go to this MISC option, and in that MISC option, select spice code. Okay, select spice code. So you can see a small square will appear when you move the cursor. Okay, when you move the cursor, a small square will appear. So click, you can place the small square wherever you want. So I place it here. I will place it at this point. So you can see a text is there, a blank text is there. Okay, a blank text we have with the name text. So we have to replace this text. So okay, we have to replace this text. So I will select this. So when I select this, it will appear a cross mark, a red cross mark. Then you press Control I for this. When it become a red cross mark, press Control I. So you can see we'll get a window. We will get a window of text properties. So whatever the code we are writing, that is by spice code. So it is written. You can see the spice code. It is written here. SPICE code. That is spice code. So it is of multiple lines. Okay. So we have to make sure that you have to check this. We have to check this multi-line text option. Okay. It has to be checked because it is the code. Whatever we are writing, it is of multiple lines. So I will check this option, then we will start writing the code. So already the code I have written for you. So we are doing first DC analysis. So I'll copy this code. I'll copy this code and I will paste it in this text properties window. Okay, so I'll paste it here. So you can see the first line VDD 0 DC5. So VDD is the name of the source. Okay, VDD is the name of the source. Then this is the positive terminal. This is the negative terminal. Negative terminal will be a ground, and its value will be 5 volts DC. It is a DC source, and its value is 5. Okay, this is the name. The first parameter VDD is the what? The name. Then the second parameter is what? Its positive terminal. The third parameter is its negative terminal. The fourth parameter is what? What type of source? Whether it is DC, AC. So it's a DC type. Then what is its value? 5 volts. Similarly, the input. The input, the name of the input is what? V in. Its positive terminal is in. Its negative is 0. Negative terminal is 0. The type of input is DC source, and its value is 5. Its value is 5. Then, so what type of analysis we are going to do? So we are going to do with DC analysis. So it will start from dot. It will start with dot. So whichever may be the analysis, it can be like DC analysis, transient analysis, frequency analysis. So it will start from dot. So dot DC, okay, dot DC. So we are varying the input. So dot DC V in 0 to 5. So we are varying the input from 0 to 5 with 1 millivolt change. With 1 millivolt change. Okay, we are varying the input V in from 0 to 5 with 1 millivolt change. Okay, then the last line is important, dot include. So whatever the text C5 model is there, so this C5 model, okay, this C5 model will contain the properties or the characteristics of this transistor, that is PMOS and NMOS. So it contains the properties of NMOS and PMOS transistors. So we have to include that in the code. So we have to include that in the code. So it is dot include G. So I have stored that file in the G drive. You can place it wherever you want. Okay, so I placed it in G drive in the folder VLSI lab, and the name of the file is what? C5 underscore models.txt. So this line is very important. So make sure that you remember means you proper uh, location or the proper path. Okay, for this C5 models underscore text. Okay, so this is the code for DC analysis. Okay, so once we write the spice code, click OK. So you can see a text will appear here. Okay, you can see the text will appear. Then after writing the code, you can save the file once again. Then to run this schematic, go to simulation spice. In simulation spice, go to write spice tech. Okay, after writing the spice code, we have to simulate this circuit with the spice code what we have written. So go to tools, simulation tools. In tools, go to simulation spice. In simulation spice, select write spice tech. Select write spice tech. So you can see when I click on write spice tech, a window will appear like this. In your case, it may be a black window like this. So in my case, it is white window because I have changed the color properties of this particular window. In your case, it may be a black one. In my case, it is white because I have changed that to I have changed the color properties. So once we get this window, go to plot settings, go to visible traces. Okay, go to plot settings, visible traces, select V in first. So I will select one input. I will select input first, then I will select what? The output. So this is the input we have. Then to plot the output, go to plot settings, then you click on add plot pane. Okay, so you can see, so we can maximize this window like this. So at the bottom we have the input, and at the top we have the output now. So we have to add what? Add plot pane. Okay, so click on add plot pane, then go to again visible traces, plot settings, visible traces. Now you select Vout. Now you select Vout. Click OK. So you can see when the input is 0, so when the input is 0, the output is at 5 volts. So as the input goes on increasing, so when the input reaches 5 volts, here you can look at this 5 volts. Okay, if you see this, if the input is at 5 volts, the output is at 0. Output is at 0 volts. Okay, output is at 0. When the input is 5, the output is 0. Okay, so this is the waveform. This is the waveform for DC analysis. When the input is 0, look at this at the bottom. When the input is 0, the output is 5 volts. So when the input is 5 volts, the output is 0. Okay, output is 0. You can see it here. You can see when the input is 5 volts here, the output is at 0 volt. Right? So when the input is here, input is 0, the output is at 5 volts. Right? So this is the waveform for DC analysis of CMOS inverter. Okay, so this is about the CMOS inverter, and that is DC analysis of CMOS inverter. So to similarly, we have one more type of analysis that is called as transient analysis. That is, we get a waveform in terms of pulses. So to so I will close this window, the simulation window. Okay, then to execute the transit analysis, so just we will modify this, just we will edit this code. Okay, just we will edit this code to transit analysis. So just I will select this code, select this, it will come a red cross mark, then you press Ctrl I. Okay, so we have to replace this code with the transit analysis code. Then I have written the code for transit analysis, so I'll copy that. I'll copy that code, then I will paste in this text window. Click. So I will paste that and I will click OK. Then you can see the code for transit analysis. Okay, so in this, again, the first line we have seen in the previous analysis. So the second line is important now. Again, in this case, whatever the source we are applying here for the input, it is in the form of pulse. It is in the form of pulse source. Okay, it is in the form of pulse source. So again, the first parameter that is Vin, it is the name of the source. The pulse source, that is Vin. Its positive terminal is in, its negative is 0. So what type of source it is? It is a type of pulse. Okay, it is a type of pulse source. So instead of DC, it is a so that the variation of the signal is in the form of pulse. Then it should vary from 0 to 5. Okay, the pulse will go from 0 and it will reach 5, and it becomes again 0, again 5, again 0, again 5. So it is in the form of pulses. So you can see, if you we can see it will be in this form, like in this form, pulse, like this. Okay, so it will be 0, then it will reach the maximum. Okay, again it will become 0 and it will reach maximum 5. So it is the fifth parameter, that is 0, from 0 to 5. And we have three zeros here, so that is the delay, rise and fall time. Delay time, TD, then TR and TF. Triple zeros here. The first zero is what? TD. TD means delay time. TR is rise time. TF is the fall time. Okay. Then, then here we have 5 nanoseconds. So what is that 5 nanosecond? So 5 nanosecond is nothing but is nothing but here is the width of on cycle, on period, is the width of on period. So here the width of on period is mentioned here. The width of on period is 5 nanoseconds. So here it is 5 nanosecond. The on period is 5. Again, the off period is what? 5. Again, it is 5, like this. So it is for one cycle. So one cycle, the on period is 5, off period is 5 nanosecond. So total it is what? So total it is 10 nanosecond. So total it is 10 nanosecond period. Okay, that is T. So that is what we have written here, 10 nanosecond. If you want, you can increase the width of on period, the width of off period. You can increase whatever you want. You can give whatever you want. Okay, so that is what we have. The second line. Okay, the second line is the pulse source. Okay, pulse source. So that is about. Then the third line is what? Dot trans. Dot trans means what? We are doing the transient analysis. So it will start from dot. So dot transient means trans, dot trans. Then 100 nanosecond. 100 nanosecond means what? Up to 100 nanosecond, we will get the waveforms like this. We will get the waveform means what? It will start at 0 and it will end at 100 nanosecond. So we'll get the waveforms from 0 to 100 nanosecond in that from 0 to 100 nanosecond. Okay, so that is the third line, dot trans 100 nanosecond. We are doing the transit analysis. So that waveform will be with respect to what? Voltage versus time. the waveform for transient analysis will be in the form of voltage. Voltage will be on the y-axis and the time on the x-axis. Remember that. Okay, remember that. In case of DC, it will be same on both the side, voltage versus voltage. Okay, voltage versus voltage. But in case of transient, it is voltage versus time. Voltage on the y-axis and time on the x-axis. Okay. Then the last line is same. Okay, if you have to include the C5 underscore models. Okay, so we have to save this now. So I'll clear it. So I will save this. Save. Then again, to simulate this code, go to Tools, Simulation Spice, write Spice Tech. Okay, so again, we'll get the blank window like this. So now go to Plot Settings again. Again, you select V, click OK. So this is the input. So to get the output, go to Plot Settings. You click on first Add Plot Pane because we want one more window. So click on Add Plot Pane. So you can see you will get a blank window like this. Now you go to Plot Settings, Visible Traces, and click V out. You can see this. When the input is high, when the input is high, when the input is high here, the output, what happened to the output? Output is low. Okay, when the input is 1, the output is 0. Okay, similarly, when the input is low, what should the output for inverter? When the input is low, the output should be what? 1 or 5 volts. When the input is 0, the output is 1. Okay, so this is the transient analysis of or transient waveform of CMOS inverter. Okay, so this is about the part A, experiment number 1, CMOS inverter DC analysis and transient analysis. Okay, so in the next session we'll see how to draw. So I will close, before that I will close this window. I will close this waveform window. I'll close this. Okay, so in the next video we will see how to draw the layout of the schematic. Okay, and we will verify its DRC, ERC, and LVS. Okay, and we will check or verify DRC, ERC, and LVS. Okay, so we'll stop it here and we will continue in the next class with respect to the layout of CMOS inverter. Thank you, everyone.